Hello and welcome to my channel. In this video we will learn the part 2 of axiomatic approach to probability in 11th class maths. So in this video we will see the probability of A or B event, that is probability of A union B, and also we will see probability of A complement, okay, and that is probability of A prime. Now in the earlier video we had studied about the definition of axiomatic definition of probability, okay, right, and then we also saw probability of equally likely outcomes. So now let us start this video by looking at probability of A or B. So probability of A or B, okay, that is nothing but A union B. So what we will do is, let us look at the diagram here, okay. So suppose this is the sample space S, okay, this is sample space S, this is event A and this is event B, okay, this is event B, okay. Then you know that this is A minus B, okay. Then this here is A intersection B, okay, and this is B minus A, right. Now let us first look at what is A union B set, okay. So A union B is equal to A, right, union B minus A, okay. This whole A union this B minus A here will give us A union B, right. And if you look at the set B, this is equal to A intersection B union B minus A, okay. So this is what we have. Now what we will do is we will look at the probabilities of A union B and probability of B. And first of all, what you see here is this A and B minus A are mutually exclusive, that is the intersection between A and B minus A is empty. So A and B minus A are mutually exclusive, okay. And similarly here what we have is A intersection B, B minus A is mutually exclusive, that is intersection of A intersection B and B minus A is empty, okay. So here A intersection B and B minus A are mutually exclusive. So if you look at this probability of A union B, so probability of A union B, since the two events A and B minus A are mutually exclusive, we will get probability of A, right, plus probability of B minus A. So this we will call it as 1 here. Now if we look at probability of B, so this is equal to, since again A intersection B and B minus A are mutually exclusive, we will get probability of A intersection B plus probability of B minus A, right. So this is the second equation. Now suppose we subtract 2 from 1, let us see what we get. So subtracting 2 from 1, what we will get is probability of A union B minus probability of B, right? So probability of A union B minus probability of B, this is the left hand side of the equation, equal to probability of A plus probability of B minus A minus probability of A intersection B plus probability of B minus A. So let us write that probability of A plus probability of B minus A, right, minus probability of A intersection B plus probability of B minus A, right? Okay, so this implies PA union B minus probability of B is equal to probability of A plus probability of B minus A, right, minus probability of A intersection B minus probability of B minus A. Okay, so what will happen is probability of B minus A minus probability of B minus A will get cancelled, and what we will get is probability of A union B minus probability of B is equal to probability of A minus probability of A intersection B, right? So this implies probability of A union B is equal to, now this minus B we will take it on the right hand side, so probability of A plus probability of B minus probability of A intersection B. Okay, so this is what we get. This is the formula. Okay, so what is the formula? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so now let us go to the next subtopic. So that is nothing but probability of not A. So probability of not A, it is nothing but A complement. Okay, so here also we will look at the diagram. So suppose this is the sample space S here. Okay, and suppose we have event A in this way. This is event A, and so the outside event will be A complement, right? This is the sample, whole sample space S, right? Now by looking at the diagram what we have here, so if we look at A union A complement, that is equal to what? So A union A complement is the whole sample space S, right? And if we look at A intersection A complement, that is empty, you know this. Okay, this is empty. So what we have is probability of, so now probability of A union A complement is equal to probability of S, which is equal to 1. We know this, right? So this implies, so since A and A complement are mutually exclusive, what we will have is probability of A plus probability of A complement is equal to 1, right? This is because since A and A complement are mutually exclusive. Okay, so now what we will have is, this implies probability of A complement is equal to 1 minus probability of A. Okay, so this is the formula. Right, probability of A complement is equal to 1 minus probability of A. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.